Now, in this lecture, we find out the radius of a circle. In the drawing, we have a right triangle, triangle ABC. Inside this right triangle, we have this circle. And our mission is to find out the radius of this circle. In addition, we know that line segment AES, this line segment AES is equal to 1 unit in its length. This is line segment ST, that is equals to 3 units. And finally, line segment TC equals to 2 times square root of 3 units in its length. And this is angle ABC, that is the right angle. Again, our mission is to find out the radius of this circle. So in the first step, we define the center of this circle, this point O. And we will define the radius of this circle, that is the radius that we are looking for, as x. Write it here that the radius that we are looking for is equals to x. According to our definition. In the next step, we will join points O and Q together by a straight line. So, what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point on the circle itself. This is exactly the definition of a radius. Therefore, OQ is the radius of this circle. According to our definition, the radius of this circle equals to x. Therefore, x of Q equals to x. You can implement here rule 1. I'll repeat quickly on rule 1. According to rule 1, tangent to a circle is perpendicular to the radius drawn to its point of tendency. So, in the drawing, we have a circle and we have tangent AB. This is tangent AB. That is tangent to this circle here at this point, point M. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM that is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. We can actually implement rule 1 in our drawing. Why? Because in our drawing, we have the radius OQ of this circle that is drawn to point Q, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees. This angle is also equal to 90 degrees according to rule 1. Likewise, we will join points O and P together by a straight line. Line segment OP is the radius of this circle, is equal to x according to our definition. We can implement here rule 1. We have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees. This angle also equals to 90 degrees according to rule 1. In quadrilateral POQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside quadrilateral POQB to 360 degrees, the missing angle here must be equal to 90 degrees in its size. So inside quadrilateral POBQ, inside this quadrilateral, we have four right angles. Any quadrilateral that has four right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral POBQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x, because they are equal to each other. Likewise, in the same rectangle POQB, OQ must be equal to the opposite side PB. But OQ equals to x, therefore PB must be also equal to x, because they are equal to each other. So we actually found out that quadrilateral POQB is not a rectangle but a square. Why? Because of the fact that all the sides of this quadrilateral are equal to each other. Each side is equal to x. So, in the next step, we'll define line segment AP as A. And we'll define this line segment QC as B. So here we can implement rule 10. I'll repeat quickly on rule 10. According to rule 10 is true in any circle. So in any circle, if we have the common extreme point P, and from the common extreme point P we draw tangent PT that is tangent to this circle here at this point T. Point T is the point of tendency of tangent PT with this circle, and we will extend chord AB until it touches point P. Again, we extend chord AB of this circle until it touches point P. So in this drawing, the following equation is true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. Okay, so we can actually implement rule 10 in our drawing. Why? Because in our drawing, if you focus on the common extreme point A, on the common extreme point A, we have tangent AP that is tangent to this circle at point P. Point P is the point of tendency. And we have tangent TS, tangent ST or TS is extended until it touches point A. That is the common extreme point. So all the requirements of rule 10 are satisfied, therefore we can implement rule 10 on this drawing at point A. According to rule 10, we get that AP squared equals to AS times AT. Repeat again. According to rule 10, if we focus on the common extreme point A, the following equation will be true. AP squared equals to AS times AT. So this equation is the implementation of rule 10 in our drawing on point A. So AP square. AP is A, therefore AP square is A square. So A square equals to AS. AS is 1 times 80. From the drawing it is very easy to see that 80 in total equals to 1 plus 3, that is 4. In conclusion, we actually found out that according to rule 10, A square equals to 1 times 4, that is 4, so A square equals to 4. Here we take a root out of this equation and finally we get that A equals to the square root of 4, that is 2. A equals to 2 units in its length. So I write it down in the drawing. A equals to 2 units in its length. Line 7 AP is equals to A and A equals to 2 units. We will implement, in the next step, we will implement rule 10 on the current point C. From the current point C, we have tangent CQ. Tangent CQ is tangent to this circle here at this point Q. Point Q is the point of tendency. So tangent CQ with this circle. And we have also chord ST that is extended. Chord ST is extended until it touches point C. So all the requirements of rule 10 are satisfied, therefore we can implement here rule 10. According to rule 10, we get that CQ squared equals to CT times CS. Repeat again. If we focus on our drawing on the current point C, we can implement rule 10. According to rule 10, CQ squared equals to CT times CS. Okay, this equation is the implementation of rule 10 in our drawing on point C. So CQ square, CQ is B, therefore CQ square is B square. And it is equals to CT. CT is 2 times square root of 3 times CS. From the drawing it is very easy to see that CS in total equals to 3 plus 2 times square root of 3. Again, CS equals to 3 plus 2 times square root of 3. In conclusion, we found out that according to rule 10, B squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. We'll open the brackets on this side of the equation and we'll get that B squared equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 equals to 12. Well, because 2 times 2 is 4, square root of 3 times square root of 3 is 3, and 4 times 3 is 12. In conclusion, we actually found out that B squared equals to 2 times 3 times square root of 3 plus 12. So B squared equals to, we substitute 12 by 9 plus 3, 9 plus 3 plus 2 times 3 times square root of 3. So this equation, this expression is very similar to the algebraic identity It says that a squared plus b squared plus 2 times a times b equals to a plus b squared. Why it is similar to this algebraic identity? Because if we define a as 3 and b as square root of 3, we get exactly that if a is 3, then a square is 9, because a square is 3 squared, that is 9. B is square root of 3, therefore b square is square root of 3 squared, that is 3, so we have here 9 plus 3, plus 2 times a times b. So it is 2 times a is 3, so it is 2 times 3, times b. B is square root of 3, here square root of 3. So conclusion actually found out that this expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to this algebraic identity, that a squared plus b squared plus 2 times ab equals to a plus b squared. So according to this algebraic identity, this expression will be equal to a plus b squared. That is to say, a is 3, so it is 3 plus b is square root of 3 squared. In conclusion, I actually found out that 9 plus 3 plus 2 times 3 times square root of 3 equals to 3 plus square root of 3 squared. According to this algebraic identity, that a squared plus b squared plus 2 times ab equals to a plus b squared. So according to this equation, b squared equals to 9 plus 3 plus 2 times 3 times square root of 3. So b squared equals to 3 plus square root of 3 squared. Why? Because of the fact that that 3 plus square root of 3 squared equals to 9 plus 3 plus 2 times 3 times square root of 3. So in conclusion, we actually found out that b squared equals to 3 plus square root of 3 squared. Here we take a root out of this equation, and finally we will get that b equals to 3 plus square root of 3. 3 plus square root of 3 equals to 3 plus square root of 3. Square root of 3 is 1.732. Therefore, 3 plus square root of 3 is 3 plus 1.732. That is equals to 4.732. In conclusion, I actually found out that b equals to 4.732 units in its length. So I can write down in the original drawing that b equals to 4.732 units in its length. So in the next step, we will implement the Pythagoras theorem in the right big triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse, this right triangle, triangle ABC, is AC. And therefore, the square of the hypotenuse is AC squared. And it must be equal to AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, in the right triangle, triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared. What is the length of AC? AC in total, it is very easy to see from the drawing that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So in total AC equals to 4 plus 2 times square root of 3. So AC is 4 plus 2 times square root of 3, therefore AC squared equals to 4 plus 2 times square root of 3 squared, and it is equals to AB squared. From the drawing it is very easy to see that AB equals to x plus 2 or 2 plus x, it is the same. So AB equals to x plus 2, and therefore AB squared equals to x plus 2 squared plus BC squared. From the drawing it is very easy to see that BC in total equals to x plus 4.732. So write it down, BC equals to x plus 4.732, and therefore BC squared equals to x plus 4.732 squared. In conclusion, actually found out that according to the Pythagoras theorem, 4 plus 2 times square root of 3 squared equals to x plus 2 squared plus x plus 4.732 squared. So, what is the value of 4 plus 2 times square root of 3 squared? Actually, 4 plus 2 times square root of 3 squared equals in total to 55.7128. And again, 4 plus 2 times square root of 3 squared equals to 55.7128, and it is equals to x plus 2 squared. X plus 2 squared equals to x squared plus 2 squared, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 squared, x plus 4.732 squared equals to x squared, plus 4.732 squared, 4.732 squared equals to 22.3918 plus 2 times x times 4.732, that is equal to 9.464x. In conclusion, we actually found out that 55.7128 equals to x squared plus x squared is 2x squared, (4 plus 22.3918 equals to 26.3918, And finally 4x plus 9.464x equals to 13.464x. So in conclusion, we actually found out that 59.7128 equals to 2x squared plus 26.3918 plus 13.464x. So here we subtract 55.7128 from this equation, and we will get that this side of the equation will be left with nothing. 0 equals to 2x squared, and 26.398 minus 55.7128 is equal to minus 29.321 plus 13.464x. Repeat again, in conclusion, I actually found out that 0 equals to 2x squared minus 29.321 plus 13.464x. Here we divide this equation, this quadratic equation by 2, and we get that according to this quadratic equation, x squared equals to minus 29, actually it is 0, that is equals to 2x squared over 2 is x squared, and minus 29.321 over 2, we divided the equation by 2, equals to minus 14.66, and 14.464x over 2 is equal to 6.732 x. So in conclusion, we get the quadratic equation that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, according to the following general formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So in the next step we'll put in our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. I'll copy again the general formula for x. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So in the next step, we'll put the data that is relevant to our specific quadratic equation in the general formula for x in order to find the value of x in our specific quadratic equation. We do it now and we get that according to this general formula for x, the value of x in our specific quadratic equation will be equal to minus b. b is 6.732, therefore minus b is minus 6.732 plus minus the square root of b squared. b is 6.732, therefore b squared is equals to 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4, times c is minus 14.66, therefore minus 4 times ac will be equal to minus 4 times minus 14.66, that is actually equals to 58.64. So it is plus 58.64 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in conclusion, I have found out that x equals to minus 6.732 plus minus, inside the root we have 45.3198 plus 58.64, and it is equals to 103.9598. So inside the root we left only with 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.9598 is equal to 10.196 divided by 2. So here we will have two solutions that are possible for x. The first solution will be x equals to minus 632 minus 10.196, that is a negative number. but this solution is incorrect solution because of the fact that x is a radius, and the radius is a length, and a length must be a positive number. So we cancel the negative solution, and we left only with the positive solution that is possible for x. According to the positive solution, x equals to minus 6.732 plus 10.196 divided by 2. So 10.196 minus 6.732 is equals to 3.46, and 3.46 over 2 is equals to 1.732. So in conclusion, we found out that x, that is the radius of the circle, that is the radius that we are looking for, is equals to 1.732 units in its length. I'll repeat again. I actually found out that the radius of this circle x is equals to 1.732 units. So in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have the right triangle ABC, and inside this right triangle we have this circle. In addition, we know that line segment AS equals to 1 unit in its length. This is line segment SC that is equals to 3 units in its length. Line segment TC equals to 2 times square root of 3 units in its length. And this is angle ABC, that is a right angle. I repeat again that our mission is to find out the radius of this circle that is located inside the right triangle, triangle ABC. So in the first step, we defined the center of this circle, this point as O, and we find the radius of this circle, that is the radius that we are looking for in this question. We define the radius of this circle as x. Then we join points O and Q together by a straight line. What is the definition of the straight line OQ, or line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, OQ is the radius of the circle, that is equal to x according to our definition. And we have the radius OQ that is drawn to point Q, that is the point of tendency BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we defined we join points O and P together by a straight line. OP is the radius of this circle that is equal to x. Again, we can implement here rule 1. Why? Because we have the radius OP that is drawn to point P, that is the point of tendency AP with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So I actually found out that you can see that inside quadrilateral OPBQ, inside this quadrilateral OPBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this missing fourth angle. In total, the sum of those four angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle A must be equal to 90 degrees in its size. In order to complete the sum of the angles inside the quadrilateral POQB to 360 degrees, the missing angle A must be equal to 90 degrees in its size. So actually found out that inside this quadrilateral POQB we have four right angles. Any quadrilateral that has four right angles must be at least a rectangle if not a square. So we will relate to this quadrilateral POQB as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO is equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x because they are equal to each other. Likewise, according to the same rule, and the same rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to x, therefore PB must be also equal to x because they are equal to each other. So actually, we found out that inside quadrilateral POQB is not a rectangle but a square. Why? Because of the fact that all the sides of this quadrilateral are equal to each other, therefore it is a square. In the next step, we define this line segment AP as A, and we define this line segment QC as B. Here, we implemented rule 10. If we focus on at point A, and then again on rule 10, according to rule 10, if you have the common extent point P, and from the common extent point P, you draw tangent PT, that is tangent to this circle at point T, and you also have chord BA, that if we extend chord BA, it will touch point P, that is the common extent point. So in this drawing, the following equation will be true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule 10 in our drawing. Why? Because in our drawing, we have the common extent point A. From the common extent point A, we have tangent AP. Tangent AP is tangent to the secant point P. And we also have chord TS. The extended chord TS touches point A. So all the requirements of rule 10 are satisfied, and therefore we can implement in rule 10. According to rule 10, we get that AP square equals to AS times AT. Again, AP square equals to AS times AT. Repeat again, if we focus on the common extent point A, according to rule 10, we get that AP square equals to AS times AT. AP is A, therefore AP square is A square. AS is 1, and AT is 1 plus 3, that is 4. So in conclusion, we found out that A square equals to 1 times 4, that is 4. So A square equals to 4. We took out of this equation and finally found out that A equals to the square root of 4, that is 2. So A equals to 2 units in its length. In the first step, we implemented rule 10 at the common extent point C. From the common extent point C, we have tangent CQ, that is tangent to this circle, this point Q, and we have chord ST, and the extended chord ST touches point C. So all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, CQ square will be equal to CT times CS. Again, CQ square equals to CT times CS. Repeat again, on the common extent point C, according to rule 10, CQ square equals to CT times CS. CQ is B, according to our definition, and it is equals to, so CQ square is B square, and it is equals to CT. CT is 2 times square root of 3 times CS. CS in total equals to 3 plus 2 times square root of 3. So in conclusion, actually found out that b squared equals to 2 times square root of 3. In the brackets we have 3 plus 2 times square root of 3. Here we open the brackets on this side of this equation and found out actually that b squared equals to 2 times 3 times square root of 3, and 2 times square root of 3 times 2 times square root of 3 equals to 12. Well, because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. So in conclusion, we actually found out that b squared equals to 2 times 3 times square root of 3 plus 12. Here we substitute 12 by 9 plus 3, and found out actually that b squared equals to 12 is 9 plus 3 plus 2 times square root of 3 plus 2 times 3 times square root of 3. So this expression is very similar to the algebraic identity that states that a squared plus b squared plus 2 times ab equals to a plus b. If we define a as 3 and b as square root of 3, and we put those two variables in this algebraic identity, we get that a is 3, therefore a squared is 9, so we have 9 here, plus b squared. B is square root of 3, according to our definition, so therefore b squared is square root of 3 squared, that is 3, plus 2 times a is 3, times b, that is square root of 3. So 9 plus 3 plus 2 times square root of 3 plus 2 times 3 times square root of 3 equals to a squared plus b squared plus 2 times ab. If we substitute a by 3 and b by square root of 3, and therefore according to this algebraic identity, this expression equals to a plus b squared. That is to say, this expression will be equal to a plus b squared, but a is 3 and b is equal to 3. Therefore, a plus b squared will be equal to 3 plus square root of 3 squared. So in conclusion, we found out actually that 9 plus 3 plus 2 times 3 times square root of 3 equals to 3 plus square root of 3 squared, according to this algebraic identity that a squared plus b squared plus 2 times ab equals to a plus b squared. And here we have the equation that 9 plus 3 plus 2 times 3 times square root of 3 equals to b squared. Therefore, b squared will be equal to 3 plus square root of 3 squared, while because of the fact that 3 plus square root of 3 squared equals to 9 plus 3 plus 2 times 3 times square root of 3 squared, according to this algebraic identity. So in conclusion, we actually found out that b squared equals to 3 plus square root of 3 squared. Here we took out of this equation and finally found out that b equals to 3 plus square root of 3. So b equals to 3, and the square root of 3 is 1.732, therefore 3 plus 1.732 equals to 4.732. In conclusion, I should have found out that b, that is the length of line symmetry QC, equals to 4.732. Okay, so in the next step, we implemented the Pythagoras theorem in the right big triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in this right big triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and AC squared must be equal to AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. AC is 4 plus 2 times square root of 3, therefore AC squared is 4 plus 2 times square root of 3 squared. AB is x plus 2, therefore AB squared is x plus 2 squared. BC is x plus 4.732, therefore BC squared equals to x plus 4.732 squared. And 4 plus 2 times square root of 3 squared equals to 55.7128. And it is equals to x plus 2 squared. X plus 2 squared equals to x squared plus 2 squared, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square, that is equals to x square, plus 4.732 square, that is 22.3916, plus 2 times x times 4.732, that is plus 9.464x. So in conclusion, we found out that 55.7128 equals to, here we have x squared plus x squared, that is 2x squared. We have also here 4 plus 22.391, 4 plus 22.3916 equals to 26.3916 here. And here we have also 4x plus 9.464x equals to 13.464x. So in conclusion, I can find out that 55.7128 equals to 2x squared plus 26.3918 plus 13.464x. Here we subtracted 59.7128 from this equation and finally found out that in this of the equation we left with nothing. And it is equals to 2x squared, and here we have 26.3918 minus 55.3128 equals to minus 29.321 plus 13.464x. Here we divided this equation by 2 and finally found out that 2x squared over 2 is x squared, minus 29.321 over 2 is minus 14.66, and finally 13.464x over 2 is 6.732x. So in conclusion, we found out that x squared was 14.66 plus 6.732x equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and the coefficient z equals to minus 14.66. Repeat again. In our specific quadratic equation, a equals to 1, b equals to 6.732, and c equals to minus 14.66. So in the next step, we will put this data that is relevant to our specific quadratic equation inside this general formula for x in order to find out the value of x in our specific quadratic equation. Okay, so we did it and found out actually that x equals to minus b, b equals to 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 squared, that is 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is minus 14.66. And minus 4 times minus 14.66 equals to 58.64. So inside the root we left with 45.3198 plus 58.64 divided by 2. So actually found out that x equals to 6.732 plus minus, and 58.3198 plus again 45.3198 plus 58.64 equals to 103.959x divided by 2. So x equals to minus 6.732, and the square root of 103.9596 equals to 10.196 divided by 2. So x equals to, here we have we have two solutions that are possible for x. One of the solutions is a negative solution, and because of the fact that x is the radius, the length of the radius of this circle, x as a length must be a positive number, and therefore we cancel the negative solution, and we left only with the positive solution. The positive solution for the value of x is x equals to minus 6.732 plus 10.196 divided by 2. And minus 6.732 plus 10.196 equals to 3.46, and 3.46 over 2 is 1.732. In conclusion, we found out that the radius of this circle x equals to 1.732 units. Okay, thank you very much.